Hey everybody, it's Dr. J, and today, we are talking about chemical equilibrium. Let's talk about chemistry. Chemical equilibrium is basically the condition of a chemical reaction in which the rate of formation of products equals the rate of formation of reactants. All right, so that's the technical definition. Now, what exactly does that mean? Right? So let's look at this example here, right? We have A plus B equals to C and D. Now, this is the very first thing that I just want to cover here, right? Because I like to think of this as layers, right? We're adding another layer now. Okay, so just looking at this, we understand chemical equations, right? We know that our reactants will form our products. And we can see this, right, with A and B representing our reactant, C and D representing our product. Now, we've only been familiar with our reactants going directly towards our products, right? For instance, if this was just a straight arrow, right, going in one direction. However, with chemical equilibrium, we have to consider both ways now, okay? So basically, we can have our reactants become our products with our rate going forward, but now we need to realize that our products, well, they can actually back react and actually reform those reactants. And this is our reverse rate. So in reality, right? So in reality, okay, we actually are going to have both of these reactions taking place at the same time, right? So we're going to have a rate going forward. We're making our products, but we also got that rate in reverse, right? So we're back reacting, making those reactants. Now, equilibrium is when both of our rates, our rate going forward and our rate going backwards, right, are equal to each other. So basically, I'm making as much product as I'm making as much reactant and back reacting, right, at the same time, right? So we're all focused on how much we're making that rate. Not necessarily, we're not really focused on the amount, right? We're focused on the rate of these things now. Okay, so that's the key thing there. So we look here, right, at an example here. NO2 plus NO2 gives me N2O4. Couple different things, just some lingo I want everybody to pay attention to. So for example, this reaction, right, if we're making products, so we're making N2O4, one thing that you're going to hear me say throughout this process is, well, I would say that the reaction is going towards the right. So what I mean by right is basically I'm saying that I'm making product, right? So in this case, the reaction going toward the right, well, I'm making N2O4. If I was supposed to say the reaction is going towards the left, right, that means that I'm making reactants, NO2 then. Now, with this specific reaction, we need to realize, and we're going to realize with all reactions, okay, is that, most of these reactions are not going towards completion. All right, as a matter of fact, it probably gets majority of the way, but it's going to fall short, right? It's always going to have a little bit of reactant left over, okay? So, when that point happens, right, well, this is a point to where our forward and reverse reactions are probably going to be the same rate, right? We're not making as much product, but we're really not making that much reactant because, we're pretty close to being done with this reaction. So basically, that's where we're reaching that equilibrium point. Okay, so we want to understand that, right? Equilibrium is about rates, not the amount, right? As I mentioned just here, we can have more products, but our rates can be the same. We can have more reactants, but our rates can be the same. Okay, so equilibrium, can't say that enough, is when our rate forward and our rate reverse are equal to each other. I just wanted to show another graph here. So we understand, right, equilibrium, dynamic equilibrium, all right, so these are basically the same. They are the same. If you see dynamic or equilibrium, it's the same thing. But just to reiterate, right, this is basically the condition which our reaction rates for a reaction will equal our reverse reactions, right? And we now understand, right, that we can have both of these reactions occurring at the same time. And we also understand, right, that the concentration of our products and our reactants does not mean that they are equal. the rates are equal, not the concentration, the total of our products or reactants, right? So this is what we're talking about with equilibrium. So for instance, let's look at this graph. This graph really sums up equilibrium. Okay, so basically, let's say we got this reaction here, and we got our forward rate. So the forward rate is basically we're making our products, right? We're making H2 and CO2. And we got our reactants here, water and CO right here, right? So the forward rate, we're making our products. And we can see, right, with our forward rate, we got our reaction rates over here. And then as time goes, right? Sorry, y'all. Time after time. You know, that just popped in my head. When you're lost and you know, and you need someone. Time after time. Okay. All right. Anyway, so if you go forward, we're making products. Now we understand, right? Over time, our reactants will decrease. And we see this with our forward rate. Right? So over time, our reactants are decreasing and it's going down, right? Because we're making more products. Now, eventually, what happens with our reverse rate? Eventually, right, we start off with no product, but as we are making product and more product, now once we make that initial amount of product, we can get some back reaction taking place. So now, right, those products are reforming those reactants. And this is occurring at the same time. So we can see, right, the rate starts to increase the reverse rate here, right? Those products going to reactants here. But eventually, we're going to reach a point in time in our chemical reaction to where our rates are going to equal the same. So that could be a point to where we made majority of this, right? And now we finally are just slowing down because it's not that much reactants to react anymore. Or any other time, right? But basically, our rates will equal each other at this point in time. Forward rate equals reverse rate. This is equilibrium. Why exactly is equilibrium occurring? Well, we can talk about kinetic theory, right? To where our molecules are colliding with each other. That's one reason, right? And then based on those collisions, that's going to impact our concentration. And as I mentioned before with the previous slide, water and CO are decreased by the forward reaction, right? So because it's decreasing, right, and we can see it up here, H2O, and then we can also see our CO here. And then over time, we start to make our products in H2 and CO2 here. All right, so before we didn't have anything, now we have our products, right? As we saw the previous slide. But as we make our products, right, the forward reaction will slow down. And as this is occurring, right, we're making our products, the reverse reaction will start to speed up. Because now we have products. Now it can actually batch react with each other, okay? And basically, I can't stress this enough. When we reach those points, right? This is where the forward and reverse reactions are going to reach the same rate. And when that happens, when that time comes, our concentrations of our reactants and products become constant. And when they become constant, basically that forward and reverse rates are the same. This is equilibrium.